So let's take a look at some of the characteristics. So I've already mentioned modes. Where are the peaks? Is it symmetrical? And is it skewed in one direction or another? So I'm just going to go over, since you guys might want to be making a histogram today and tomorrow when you're working on your projects, what I've done in order to create it. So first take a look at column C and D. Those are just numbers. So all you've got to do is type in what ranges you want your histogram to include. And you can use the fill down function to do that more easily. Right? So I'll show you what I mean by that. So if we have 0 and 0.1, and that tells us that we want values or ranges of 0.1 width, and then I'm going to type 0.1 again to 0.2. I just use the tab to enter and advance to the next cell. Then we're going to select these, pull down to 10, and it'll fill out our ranges. So that's the part where we define our ranges. In cell E, we're going to use this Excel COUNTIF function. Right? So that's, if you can't see that, that's in your shared folder. And that counts how many cells in the first range given, which is column A, that are greater than C1. And then this COUNTIF counts the number that are greater than D1. When we subtract the two, we get the number that are greater than C1, but not greater than D1. And that's the number between 0 and 0.1. Everyone follow that? So you guys don't really need to figure out the COUNTIF function yourself, because that is somewhat complicated, but I've given it to you. That's how you create your frequency column. And then to make the dot plot, we use the REPT function, and that repeats whatever the first argument is, which in this case is just a bullet character, and then E1, the number, over 2. So that tells us to print one dot for every 2 occurrences of a value between 0 and 0.1. Everyone follow? So outliers. I was mentioning before with our standard deviation that when we added that value 9 that was way far away from the 0 to 1 range, we increased our standard deviation considerably. And that 0.9 is an exception. There are always exceptions. For instance, in a data set of the ages of students in, say, an engineering class, a mature student, right, someone who's gone back to school, would be an outlier. Most of them are going to be in the ages of, if it's first year class, 17 to 19. And we might have someone 59 in there, right? That outlier is going to bring the standard deviation way up. And not only that, but he'll pull the mean way up. And that will skew our data. That will show something that's not actually true. Another example of outliers is in traffic. If we have a list of data of how long it takes a bunch of vehicles to make a certain route, cars that pull over or stop or do something along that route and then continue are going to be outliers, because they're going to be way longer than the actual travel time is because they stopped. So what do we do about them? We generally exclude them from our calculations. So we would, if we want to have the average age of students in an engineering class, we'd probably exclude the mature students, because they're going to pull the average age up to mid-20s because they're so far from the mean, even though there are so few of them. And they're going to pull the standard deviation way up as well. And again, in the case of traffic, of course, we don't want to include cars that pulled over and stopped in our calculation of travel time, because that has nothing to do with the transportation basics that I got mentioned yesterday, right? We don't account for cars pulling over in density or flow, and therefore we shouldn't in speed either. So now we're going to start looking at the data that you guys collect or started collecting on Tuesday from the EC2 site, which is ultimately from the CP24 news site. So before I start on that, does everyone understand what we've covered so far? So histograms, standard deviation, mean, outliers? Great. So the first thing we're going to do is pull up one of these data files. So head over to your shared folder, and you should see a data folder with a bunch of files in it. And you can pull up one of those. So I'm going to say take the 26th of July, just for the heck of it, see what we get. So the first thing you might notice, if the time column looks like this, those number signs means the value is too large to fit, so just make it bigger. And we can see that I've included a number of things that were not there when you first collected the data, such as the time in Excel format and headers that tell you exactly what it is, and as well when you scroll down, the headers stay put. So let's take a look at what everything means. I explained this to some of you on Tuesday, but now we'll get everyone to have a full understanding. So column A contains which road it is. So in this case, 400 northbound. 400 is a major highway around Toronto. And 401 to King Road, those are two other major roads that run crossways to the 400. And it's saying that it's the northbound section of the 400 between those two roads. So we have our actual time. Yes? Let's see. OK, so you're going to make the column H wider. Do you know how to do that? Not quite. Move up a little bit between H and I. There you go. Everyone else have your time column. So if you didn't see, the way you make a column wider is go between H and I. You should see arrows like this, and you can drag it around. Right, so we have the road that it's on, and if we go to column H, we see the time that it happened at. So this is 12:13 in the morning, and columns F and G also say that. They say that it's hour 0 on a 24-hour clock and minute 13, right? So that road at that time has a travel time of 39 minutes. So that was the instantaneous travel time at that time, and its average time is only 15 minutes. Which means that our delay is 24 minutes, right? So we have a 24-minute delay, and that delay can also be measured in percentages, which is 160%. That makes sense to everyone? So one thing that you might find necessary to do is, since our Python script actually put out a blank cell if the delay was 0, and didn't put out any percentage if the delay was negative or 0, we can go ahead and fill that in. So to do that, to calculate delay, we can type equals, and then we want the actual time minus the average time. So in this case, it's going to be B2 minus C2. Hit enter, and that'll calculate 24 as expected. And then you can pull that down, and that's going to fill in the zeros that we missed. Solomon, you okay? Yep. Have I shown that on screen? Let me put that up for you. Right, so equals B2 minus C2 equals our actual time minus our normal travel time. Everyone have that? Put your hand up if you need help. Francis, can you handle that? Great. And another thing is, since percentages don't show for zeros or for values that are negative, if you want to use those, we can fill them in as well. So in this case, instead of B2 minus C2, we're going to go equals B2 divided by C2. Or sorry, not C2, our delay is what we want. So our actual time divided by our delay. And this is a what's called a proportion. If we want a percentage, we can just go ahead and multiply by 100. And again, pull down. Right, so we can see, say that in column or in rows 4, 5, and 6, our delay is 100% because the travel time is the average. So it's 100% of the average travel time. Is anyone having trouble with that?
Mine it says divide by 0.
Okay. Sorry about that. I was actually mistaken the second time, not the first. So it is B2 over C2. Sorry about that. So that's the formula you should have in E2, and then you can pull that down. Yes. Okay, it's a bit tough to see it there. Equals B2 divided by, so slash, yep, C2, times 100. Yeah. There you go. Yep. Yeah, I should also note that if you don't have 100 in cells or in rows 4, 5, and 6, that might just be because you're using a different day of data. Anyone else still having trouble? Put your hand up if you are. Yes, Andrew. Okay. So do you know what delay means?
Yeah.
Right, so delay is the difference between the actual travel time and the average. So to get the difference, you're going to type equals. Yep. B2, that's our actual travel time. Yeah, and then minus our average travel time. Hit enter. And there you go. So you see that our actual time is 8 minutes, our average time is 7 minutes, so our delay is 1 minute. And then you can drag that down. So for the other column, we're going to do B2 divided by C2, right? And that times 100 to get a percentage.
Okay, 10,000.
Excuse me. Oh, is the rest of them okay? You guys all good? Pardon? It's weird? Oh, yes, it is a very long data set, so it might take you a couple seconds to drag it all the way down.
Instead of dragging shift control down, select all of it, and then control D.
Okay. Yeah, so Agot mentioned something else that you can do. To drag it down, you can do shift, then control, then down, which will select all of it, and hit control D to fill down. So I'll write that down if that helps anyone. Anyone else still having trouble? Put your hand up if you need help. Great. So, these data are currently not in a very useful format. We have one road, then the next, then the next, then the next, all at the same time, but the usage of data sorted by time is limited. Can I get everyone's attention, please? No one else needs help? Are we good to move on? Great. So we note that the data are not sorted in a very useful fashion. Right? The data are sorted by time. Normally you want them to be sorted by time first, so that we have each road separate from one another. Normally we want to be comparing one road to itself, rather than to another road at the same time. There are instances where we want to do that, but it's good to learn how to change it around. So we're going to sort these data. To do that, we go to the Data tab. Make sure you've selected all. You can do that by either hitting Control A. Yeah. Oh, that's not Control. There we go. Control A, or dragging across all 8 columns. And then in the Sort and Filter section, hit the Sort button. Right? And we should see this. So I'll show that. Right, so select all, go to the Data tab, Sort. And now once we see this dialog box here, we're going to select in the first one, road, then values, then A to Z. So we have values in A to Z already selected, so we'll just hit road. And then we're going to go OK. So take a look at what's happened now. Now we have all of the same road in sequence beside one another, and the times going up incrementally. These times actually aren't incremental, so what we'll do to fix that is add another level of sorting. So again, select all, data, sort, and we see this that we've seen. Now we can go ahead and add level, then by time, values, smallest to largest. So it first sorts the road. So we first have all the 400s, then all of whatever's alphabetically below that, and then it sorts by time. So since the 400s are the same, we sort the lowest time, then the next, all the way up. Just time. Yeah, sorry, it's a little confusing there. Time minutes means travel time. Time without bracket minutes means the time of day. So in here we want time at the bottom. We don't want time in minutes. We just want time. That was a bit confusing. Put your hand up if you still need help. All right. So now what we can do is go ahead and make a scatter plot of these data. So I'll show you how to make a scatter plot. Yeah, I'm sure a number of you have heard that before in your classes. So first we'll try plotting based on just the delay itself. So to do that, we're going to select all of the delays at one road. In this case, the delays aren't very interesting because they're all -1s. This one's a little bit more interesting. This one's good. Let's take a look, in my case, at Highway 400 northbound. And I'm going to select all of the delays in the Highway 400 northbound. I'm just going to keep going down until I hit the next road. There we go. Right? So I've selected these. And then we're going to go, again, insert, line, 2D line. And this shows us the delays as they move along in each time that we collect the data. Right? So we can see that initially there was a lot of delay, and then it kind of jumped up and down considerably for about 2 hours. And then for most of the day it was okay, and then we had another peak. So it looks like we all need a little bit more time to get that done. Some of you have. Put your hand up if you need any help. Pardon? I used on the 26th the Highway 400 northbound between King and... But you guys don't have to use the same road, and in fact, some of you guys may be using a different day. So you will see a different graph show up. The important thing is that you get a graph that looks somewhat like this. It might just be a bunch of -1s if you chose a day that wasn't very interesting in terms of delay. Sorry? Right, so to do that, you've got your, okay, so that's all of your data throughout all of the roads. So that's going to put one road and the next and the next and the next. That's going to be difficult to intuitively understand. So start by selecting, we can go with the last one. So start by selecting the very last cell in column D.
Oh, okay. The very last cell.
Yeah. Yeah, that was not very interesting either. Okay, and then drag it up. Or sorry, not drag up like that, but select up.
Oh.
Right. And keep going up until that QEW westbound changes.
What?
There. Okay, so stop there.
Okay.
Go back down. So you see that we have 427 to Trafalgar. Keep going down.
There.
Yeah, right?
Right here.
There you go.
No, but there's another 3 there.
That's fine. Keep going up to this point here. And stop. So that's selecting all of the data for the delays on QEW westbound from Trafalgar to Brant on the 26th of July.
So you're only selecting QEW westbound?
Yeah, so we only want one data set.
Okay, now I get
So
the-
now you're going to go insert, line, there you go.
Oh, it looks different than the others.
It looks different than the others because it's a different road. It's the same day as most people are using, but it's a different road, right? So all of the different roads have different delays, but the point is to get you to learn how to graph them. Anyone else need any help? Noticing most people have a graph up there. What's that you've done, Jordan? Oh, you graphed everything. Did you get this initially? Okay, so you have, so you want to find a road that you want to graph on. So pick one, say 400 southbound looks like it might be okay to use. So you want to find the start of Highway 9 to King Road. So scroll up a little bit. Yeah, there you go. And then select the delay on that start row.
Like this?
That's the delay in percentage. You can use that too. Yeah, and then select down. So don't drag down, select it down. There you go. And keep selecting down until it changes to a different road. So it'll likely still be 400 southbound, but it'll change which segment. Okay, there you go. And now go insert, line, first one. Right, so that doesn't show quite as interesting a peak as some of the other roads are showing, but that is properly the plot for it. So you can try it with some different roads and see what you get. Is anyone else getting stuck? Does everyone else have a graph that looks something like this? Looks like most people do. Will, is everyone okay on that side?
We're plotting the delay minutes or
You can plot minutes or percent.
but it's like always at 100%.
Pardon? Okay, let's see what, yeah. So in this case, that's actually not a mistake that you've made. That's just that the data on that day aren't very interesting. They're all about this. Oh, so you're right, they are. So let's see what you're doing to plot it. Insert, line, click the first, oh, okay. Click the first one. What that does is that actually normalizes them all to the same value. So line, there you go.
Do all this when I open another file.
Yes. So insert, line, and the first one. Yeah. So I'll show that. When you go to insert, it's line and this first one here.
I got one graph, right? One whole row.
Okay, so in this case, we're not actually doing a scatter just yet. So go line, and then that first one. Yeah, that isn't a very interesting day, but that is
Essentially
what
you're
it
supposed
looks
to-
like, yeah. So what you can do is you can try selecting a different road, right? One that looks like it has more interesting values and see what you can get for there. So for those of you who are finished, because I know a lot of you are, you can certainly try selecting different roads. What you can also do is when you have your chart selected like this, you'll see a blue box appearing around the data you're charting. So you can go up and find the corners of that blue box. Might be a fair ways up. And you can actually drag the blue box to make it smaller or larger and drag it around. So we can drag the blue box over to percentages to get a plot of percentages instead. And go down and we see a similar looking chart. It's just a different scale. So we can see here that at one point it reaches 400% delay. All right, so I'm going to move on to the next section. If anyone's still having trouble, feel free to call Will or Francis or Agop, or put your hand up if you are. So now what we're going to do is we're going to take a look at this plot that you should all have. And what do these numbers on the bottom mean? Does anyone have any idea what they mean? Yes, James?
Time in minutes.
Okay, so James is saying time in minutes. Any other ideas? Robbie? Right. So these are actually just the index of the values. But what James said is in no way incorrect, because the index of the values doesn't mean much beyond our internal representation of it. We want time in minutes, right? We want to be able to say, when does this peak occur? I don't know. At index 183, what does that mean? We want to plot it with regards to the time. And to do that, this line plot isn't very helpful. We want to use a scatter plot. So we can go ahead, select that chart, and delete it. Okay? And in order to create a scatter plot, first we want to have our data at hand. So I'm going to go find the start of this 401 to King Road, which is up here. And now, without selecting any data, all right, is everyone listening? Without selecting any data, because it's easy to go wrong if you do, go to the Insert, and under Charts, Scatter, and use the first one. Okay, this is wrong. The reason that's wrong is because I actually had one cell selected. So instead of, make sure that you have selected a cell that doesn't have any data in it. And again, Insert, Charts, Scatter. And now you see a blank chart. The reason it's blank is because we didn't select any data. It doesn't know what to chart. Yeah, so Francis, you want to delete that and repeat the steps, but have the cell that you're selected be empty. Okay. Yeah, use a different one. Has everyone else got this blank chart here? All right, so I'm going to keep going because it looks like most people have it. You can call one of the counselors if you're still having trouble. And so now we're going to select the data that we're going to plot. To do that, it's a matter of right-clicking and clicking Select Data. So we should all see this dialog box showing up. And we're going to add one entry. And this pops up this box. And we don't need the series name. We don't need to worry about that. And under Series X values, we're going to select our data now. So go to this box, and now we can go and select the data. So in delay, I'm going to start at the beginning of this 401 to King Road, and I'm going to drag down until I get to the end. So I see it's now changed to King to Highway 9. And so I've selected all of the data on 401 to King Road. Has everyone got that done? So now we should see a value that looks something like this in the sheet X value, or in the series X values box. I'll give it a second for you guys to catch up. Yes. Pardon? Okay, so for series X values, you want to go to that box, right? And now you can select your values.
Okay.
right? So you then just go and select the actual ones you want. Put your hand up if you're done. Put your hand up if you still need help. I've only got a quarter of the class represented here. Yeah, Michelle, are you done or do you need help?
Should I switch
Pardon?
the X and the Y-axis?
Okay, so that's probably because they just actually were on that day, so find a different road.
But this is the third Excel sheet I've opened up.
Pardon?
This is the third one I've tried. Is there
If you scroll down, you'll see. You can hit page down. That'll do it more quickly.
Should I?
Right, so now you can see some differing delay values. So you can find one that has some values that look interesting, and that one looks interesting, so you can plot that. Pardon? That's a good point you brought up. Yeah, so Robbie did point out a mistake that I made. What we selected is the delay that we actually want on the y-axis. So to do that, we can just copy this value in series X values and paste it into the y values box. You should also be able to, if y values is empty, drag it. And so now to repopulate the x values with what we actually want, we need to use time. So to get time, we want our x values to be the time column. And actually, it'll work, leaving both x and y to be the same thing. So if I hit OK, OK, it'll do that. And now we have both of them being the same. So I can actually drag one of them over onto the time column. And in this case, we have both on time. So to fix that, we need to switch them. So again, right-click, select data. And in this case, we've already added the series. So we're going to go Edit, and we can switch them around. So I'm going to copy that, paste it into here, and then move this one over to the other box. So give me just a sec to get this right. All right, so I'm going to start over because it looks like I need to, but as well, anyone who's stuck can follow again. So insert, scatter, make sure you have nothing selected. And I'm going to move this off to the side so that it doesn't get in the way of my time column, because it did before. Select data, add, and so for x, we're going to select time. So I want 400 northbound until we get to the new road. So I'm going just the 401 to King Road. And then for our y values, delete it, make sure there's nothing in there, and then we'll select the data for 401 to King Road. And if we hit OK, now we have what we wanted, which is a scatter plot plotted against delay and time. So now we can see that this peak occurred at, it's not very well labeled, but at around 5 o'clock. So this was the afternoon rush hour. All right, so I'm noticing Robbie's got some interesting data there. James has got it done. Anyone else still having trouble? Okay, so Jordan, what you need to do is when you create your scatter plot, make sure that you have an empty cell selected. So yeah, there you go. And now add a scatter plot.
Could I make this thing larger?
Pardon? Yeah, that's good. You've got it.
Could I make it larger?
Oh yeah, so to make it larger, you can find the edge here and click and drag. Yes.
What do I do?
Okay, so select an empty cell. I'm going to actually demonstrate on the front so everyone else can see as well. But I'll be focusing on what you're doing there. So you have that empty cell selected. So I'm going to delete this and do it again for those who need it. We're going to go Insert, Scatter, and click the first one. Drag it out of the way. Right-click our scatter. Select Data. Add. So then for series X values, we're going to select the X values on one road. Or sorry, for X values, we don't want delay, we want time. My bad. So make sure there's nothing there, and select the times. Yeah. Hi. It should be, I'm not sure if it's quite filled out yet. Have you got that, Kartik? Let me. Right. And so now that's for series name. So drag that down to X values. So copy that and paste it in X values. It won't paste? Okay, well, I guess select it again for the X values. So select start from the time and go down. And again, for the Y values, make sure it's empty. It doesn't have that equals 1. And now we're going to select the delay. So we start on 401 to King Road, delay, and I'm going to drag up. Anyone else need help? I'm noticing most people have something there.
This is completely.
Right. Okay, so let's see. So yeah, why don't you try starting again? Or so X values, now drag the time. Yep. And drag it down to select the rest of that. And then for Y values, select the delay. Yes, that. So okay, look. Let's see what you've done. So we have time and delay is it get very negative here? So somehow this is actually, oh yeah, it does. So you know what? That is correct, yes. You found an interesting case in which the delay becomes very, very negative. So for some reason, that road was a lot faster than it should be.
It's just a foreign road.
Actually, just one thing to check. I see what you've done. So you've actually calculated your delay backwards. So you want B3 minus C3. So that's what happened. That's why your graph looks upside down. How you guys doing, Matthew and Senior? Okay, you've got it. How about you, Matthew? Yeah, that's correct. And so you can see what time that occurred at. So you can see that we have our morning and afternoon rush hour peaks. All right, so what I'm going to do is I'm going to cover the last element of this morning before I break off into groups very quickly, and then we can work on getting anyone else who's still got problems figured out once that's done. And this might actually make this job a bit easier, is how to filter. So to filter data, again, we're going to select it all, go to the Data tab, and then click Filter. And all that does is shows these arrows, and with these arrows we can hide certain roads. So to show only 400 northbound, we can select, or when we do this down arrow, click select all and deselect that, and then click 400 northbound. That'll select just that one road, and now we show only that road, which only shows a couple of data and makes it a lot easier to deal with.
Select all of these or something?
Yeah. So are you looking to do the filtering?
Yes.
Okay, so select columns A through H. Use the columns up top. And now go filter. There you go. All right, so it looks like most people are okay on filters. So select columns A through H. So that's making A bigger. Go right on A, not on the edge. And you can do that, yeah. Data, filter. It's a button in the middle. There you go. All right, so what we're going to do now is we can continue on helping people get sorting, filtering, and graphing data for the rest of the morning. But what we're going to do so that everyone who's got that done has something to do